So very good afternoon to one and all. We are continuing our lectures. So we were discussing about the different manufacturing process. So in the first class we discussed about I give you an introduction to the manufacturing. What do you mean by manufacturing? And we also discussed about the casting. That's one of the conventional manufacturing process. And thereafter we discussed about the forging. So while discussing, I told you, so it's a metal forming process. So it's a classification, it's a manufacturing process. At the same time, it is categorized under the manufacturing process as metal forming process. Okay, so while discussing forging, I told you about what you mean by a metal forming process. I hope you are remembering. So the metal forming means it's a manufacturing process which is also known as the mechanical working of metals. So the forging, rolling, extrusion, etc. all falls under the category of metal forming. So what is meant by metal forming? Yeah, as the name implies, the main objective of the metal forming process is to provide desired shape and size under the action of externally applied forces in metals. So under the action of externally applied forces in metals, we are changing the shape, size, etc. So that is the main objective of the metal forming process. See, such processes are widely used to obtain or to achieve optimum mechanical properties and reduce the defects. So there are different type of metal forming process like as forging, rolling, extrusion, and we discussed about the forging already. So what was forging? Do you remember? Yeah, we are reducing the or we are changing the size and shape by the application of compressive loading, isn't it? Yeah. So today we are going to discuss another two important metal forming process, which is rolling and extrusion. Let's see what do you mean by rolling. So if you look at the diagram itself, you can easily see what you can obtain from a rolling process. Alright, you can see two rollers, and in between I have passed a workpiece in between, and if I pass my workpiece with a desired thickness through these two rollers, as an output I will get um, a cross section of reduced thickness, isn't it? So which means the rolling is a metal forming process in which the material is allowed to pass between rotating rollers in order to reduce the thickness and to obtain desired cross section. So it's a metal forming process in which the material is allowed to pass between rotating rollers. You can see two rollers. One is rotating in a clockwise direction, the bottom one, and the top one which is rotating in an anti-clockwise direction. And in between, I pass my material between the rotating rollers. As a result, I get a cross section with reduced thickness. Okay, so while passing this workpiece between these two rollers, two things are happening. One is a squeezing of the work material. Both squeezing and pulling. These two things happening while passing the material between the two rollers. I mean, when you pass the work material between the two rollers, to pull and simultaneously squeeze the work material placed between them. And because of the high production rate and possibility of close dimensional tolerances, this process is one of the widely used metal forming process. Okay, so I can say it's a process of forming metals into desired shape by passing the metal in between a pair of rollers. Yeah. Um, so by using this rolling process, you can see different nice pictures I have included in this slide. So different cross sections which I can fabricate using a rolling process is displayed in the slide, like bars. You can see plates, you can see sheets here, you can see rail type cross section, you can see other structural cross sections. All these type of cross sections can be shaped or formed using a rolling process. And I can generally classify the rolling process into two: a hot rolling and cold rolling. See, the hot rolling and cold rolling means the hot rolling is a metal working process that occurs above the recrystallization temperature of the material. While discussing the recrystallization, I think while discussing the forging process, I also discussed what do you mean by a hot forging and a cold forging. A hot forging is a process carried out at a temperature above the recrystallization temperature. I hope while discussing the hot forging, I told you what is recrystallization. Recrystallization is a process by which deformed grains are replaced by new set of defect free grains. ഒരു മെറ്റീരിയലുള്ള മേ ബി ഒരു കോൾഡ് വർക്കിംഗ് ഓപ്പറേഷന്റെ ഭാഗമായിട്ട് ഒരുപാട് ഡിഫക്ട്സ് ഉണ്ടായിട്ടുണ്ടാവും. ഈ ഡിഫക്റ്റീവ് ആയിട്ടുള്ള ഗ്രെയിൻസിനെ റിപ്ലേസ് ചെയ്ത് ന്യൂ ഗ്രെയിൻസ് ഫോം ചെയ്യുന്നു. ആൻഡ് ഇഫ് യു അലൗ ദിസ് ടു ഹാപ്പൻ, the material get good properties, say sometimes mechanical properties, or you will get desired properties. And how this recrystallization happens? It happens at a particular temperature. You need to heat the material at a particular temperature, say recrystallization temperature. So similarly, the hot rolling is a metal working process. What you are happening? What was rolling? I am passing the work material between the two rollers, and there become hot rolling. I am heating the material to the recrystallization temperature and passing in between the two rollers. That is called the hot rolling process. So hot rolling is a metal working process that occurs above the recrystallization temperature. What would be then cold rolling? Rolling process occurs below the recrystallization temperature of the material. So that is the difference between a hot rolling and a cold rolling process. And in order to obtain the rolled product, so you need to pass the work material between the two rollers. By arrangement of rolls for the rolling operation, ആ ഒരു സെറ്റപ്പിനെ പറയുന്നതാണ് റോളിംഗ് മിൽ. So the arrangement of rolls for a rolling operation make a rolling mill. So the rolling mills are classified into different types. So the arrangement of, we are going to discuss about the different type of rolling mills. So what do you mean by a rolling mill? The arrangement of rolls for a rolling operation constitute a rolling mill. So the rolling mills are classified on the basis of the number of rolls used and the type of arrangements, and you can classify it into a 2-high rolling mill, a 3-high rolling mill, a 4-high rolling mill, and a cluster rolling mill. You can classify the rolling mill into different types. Let's see one by one. What do you mean by a 2-high rolling mill? എന്താണ് ഒരു 2-high rolling mill എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ? If you look at the diagram, you can see that in a 2-high rolling mill, 2 rollers are used for performing the rolling operation. You can see that there is a top roll and a bottom roll. The top roll rotates in an anti-clockwise direction and the bottom one rotates in a clockwise direction. 2 rollers are used for performing the rolling operation. And when you pass the work material between them, and you will get the output as the desired thickness. And the reduction in thickness, and this reduction in thickness of the work material is possible in a single stage. And I can say another important point, that the 2-high rolling mill is reversible. Why it is called reversible? Which means the movement of the workpiece from one side to another during a rolling process is called a pass. Please note that the movement of the workpiece from one side to other during a rolling process is called a pass. So in a reverse mill, a reverse pass is possible. So in the case of a two-high rolling mill, the reverse pass is possible. So that's why it's called a two-high rolling mill is reversible. And next one is the three-high rolling mill. So what would be the three-high rolling mill? So in the case of a three-high rolling mill, you can see three rollers are used for performing the rolling operation. നേരത്തെ രണ്ട് rollers ആയിരുന്നു യൂസ് ചെയ്തത്, ഇവിടെ three rollers. And I will say the reduction in thickness of the workpiece can be done in two stages. എന്തുകൊണ്ടാണ് അങ്ങനെ പറഞ്ഞേ? You look at this. Initially I pass my work material between these two rollers. ഇതിന്റെ ഔട്ട്പുട്ട് ആയിട്ട് കിട്ടുന്ന പ്രൊഡക്റ്റിനെ I pass it between these two rollers. So my the desired final thickness is this one. So how I obtained? I pass the work material in two stages. So it's a two-stage process. I mean, firstly the strip is passed between the middle and bottom rollers such that the single stage reduction takes place, and the deformed strip is again passed between the top and middle rotating rollers in opposite direction so that the desired thickness is obtained. So in this type of rolling mills, the extreme rollers, that is the top one and the bottom one, are rotating in the same direction while the middle one rotating in the opposite direction. Okay. So in a two-high rolling mill, the workpiece is rolled on both forward and return pass without stopping the process. And so hence the efficiency is more compared with the two-high rolling mill. So that's called a two-high rolling mill. I hope you understand. Next one would be, what do you mean by a four-high rolling mill? So in order to reduce the force required for the rolling operation, in order to please note this point, why I am moving to four-high rolling mill, in order to reduce the force required for the rolling operation. എവിടെയാണ് force ആവശ്യമായിട്ട് വരുന്നത്? അതായത് at the same time the rollers are rotating, you need to press this material, then only that reduction in work material thickness will happen. അപ്പോൾ ആ roll force കുറയ്ക്കുന്നതിന് വേണ്ടിയിട്ടാണ് ഈ four-high rolling mill യൂസ് ചെയ്യുന്നത്. അതെങ്ങനെയാണ് കുറയ്ക്കുന്നത്? Let's see. You can see that in order to reduce the force required for the rolling operation, the roller diameter has to be reduced. Okay, and if you do so, which in turn reduce the load bearing capability of the rollers. Okay, resulting, and otherwise it may cause failure. So, and how you can manage this situation? So this condition can be avoided by using backup or supporting rollers. So in a four-high rolling mill, the centers of all the four rollers must lie in a single vertical axis. If you look at this, you can see that the centers of all four rollers must lie on a single vertical axis. If that is not satisfied, the system may fail. So you can reduce the so you will get the hot and cold rolled plates and sheets using this process. So that's called a four-high rolling mill, which means it consists of four rolls, two of which are working rolls and the other two are backup rolls. So ഇത് രണ്ടുമാണ് backup rolls. ഈ small രണ്ടെണ്ണമാണ് working rolls. So the one which is in contact with the metal strip is called the working rolls, and the other two are called the backup rolls. Okay, I hope you understand. So as I told you, the backup rolls have larger diameter and are used for preventing the deflection of working rolls. Working rolls in the deflection ഒഴിവാക്കുന്നതിന് വേണ്ടിയിട്ടാണ് we are using backup rolls. Another important type is called the cluster rolling. എന്താണ് cluster rolling mill? What do you mean by a cluster rolling mill? So the cluster rolling mills are special type of four-high rolling mill. Please note that the cluster rolling mills are special type of four-high rolling mill in which each smaller roller is supported by two or more supporting rollers. Each smaller roller, if you look at this one, it is supported by these two. Similarly, this one is supported by these two. So each smaller roller is supported by two or more supporting rollers. So this process is commonly used for rolling hard but thin materials. Okay, for such materials, if you want to get such kind of materials, the rollers of small diameter and considerable length must be used. So the additional rollers used here, which will provide adequate support to the working rollers. So mainly used for cold working operations. So that's called a cluster mill. Okay, actually this cluster rolling mill used for rolling very thin sheets or foils. That's about the cluster rolling mill. And another important type is the tandem rolling mill. The tandem rolling mill, as you see in this diagram, you can see that in the what we discussed, the 2 hair rolling mill discuss 3 hair discuss 4 hair discuss cluster rolling mill discuss in all the above rolling process, a continuous pass of work material between the rollers is not possible. So this will increase the manufacturing time. So for a mass production, a set of 2 or 3 stands of rollers are placed in series, as in this schematic diagram shown in this slide. So for the mass production, a set of 2 or 3 stands of rollers are placed in series such that a continuous reduction in thickness is possible in a single stage without stopping the rolling process. So that's called a tandem rolling mill. And another important type is called the planetary rolling mill. So the planetary rolling mill, if you look at the diagram, you can see that this type of mill has a pair of large and heavy rollers surrounded by a number of small rollers. This is a heavy one and surrounded by some small rolls. So in this mill, in this rolling mill, the slab can be reduced directly to a strip in a single pass. Okay. So these are the different type of rolling mill, and again we are going to discuss about another important title, another important metal forming process, which is called extrusion. It's called the extrusion. Let's see what do you mean by an extrusion. So the extrusion, this is also a metal forming process. You can, if simply I can say to you that in extrusion a cylindrical billet is forced through a die. A cylindrical billet is forced through a die. Okay, so in a extrusion process, you will have a cylindrical billet, round shaped billet with you, and you are forcing it through a die so that as per the cross section of the die, depending upon the cross section of the die, you will get a reduced billet or reduced part out of the extrusion process. And both metals and alloys and again plastics can be extruded, and from where you this word coming from, so the word it is actually coming from a Latin word extruder, which means to force out, to force out. നമ്മളെ ഒരു രാവിലെ നിങ്ങളുടെ ടൂത്ത് ബ്രഷ് ചെയ്യാനായിട്ട് യൂസ് ചെയ്യുന്ന ടൂത്ത് പേസ്റ്റ് കണ്ടിട്ടുണ്ടോ? ആൻഡ് വാട്ട് ഈസ് സിംപ്ലി ഹാപ്പനിങ് in it is a extrusion process. You are allowing the paste to pass through a small die, and you will so it's something you can imagine nicely. Don't compare with the actual extrusion process in order to get a feel of what actually what is basically an extrusion process. I just said an example. Okay, so that is a characteristics of extrusion. Large deformations can take place without fracture. So the material undergoes high value of strain. So large deformation can take place without fracture. So simply I can tell you the extrusion is a process by which a block of metal is reduced in cross section by forcing it to flow through a die orifice under high pressure. Okay. And then what are the sorry I'm sorry okay, so there are two types of extrusion. One is hot extrusion and cold extrusion, and the hot extrusion process is the one in which the extrusion is carried out at elevated temperature. Similarly, the cold extrusion is the extrusion which is carried out at low temperatures. Now this is actually a schematic diagram I would like to showcase to you in order to get a feel of what does it mean by an extrusion. Okay, how does it happen? What is the cross-sectional view of a extrusion die? Actually, here you can see that this is actually the die. You can see that ഇതിനകത്ത് ഡൈയുടെ ഷേപ്പ് നോക്കി കഴിഞ്ഞാൽ ഒരു സർക്കുലർ ഷേപ്പിലായിരിക്കും. അതുകൊണ്ട് തന്നെ ഇതിന്റെ പുറത്തോട്ട് വരുന്ന പ്രൊഡക്റ്റ് ന്റെ ഒരു ക്രോസ് സെക്ഷനും സർക്കുലർ ആയിരിക്കും. Depending upon the shape of the orifice, the shape of the extruded cross section can be different. If it's a hexagonal or if it's a square, whatever be the shape of the die, you will get the reduced cross section in that shape. Now, what are the typical products made by an extrusion process? What are the typical products? One is railing for sliding doors, window frames, tubing having various cross sections, aluminum ladder frames, numerous structural and architectural shapes. You can obtain a variety of products using this extrusion process. And what are the commonly extruded materials? Aluminum, copper, steel, magnesium, lead, these are the commonly used extruded materials. And another important feature of extrusion process is you will be able to orient the grain in a favorable direction, usually in an axial direction, uniaxial direction, or that is one of the very advantages of a extrusion process. You will be able to orient the grain in a favorable direction. And let's look into two important type of extrusion. One is called a forward extrusion and another one is the backward extrusion. The forward extrusion process is also known as direct extrusion, and here the extruded metal flows in the same direction as the of the movement of the ram. Look at the diagram. Look at the schematic diagram. You can see a container, and you can see a work billet, and you can see the die. You can see a ram. Actually, this ram which applies pressure on this working billet, and once it applies, similarly like when you press on the toothpaste, when you press the toothpaste on using this your finger, you are giving the pressure, and here what the ram is applying the pressure on the working billet and allowing it to pass through the die, and you will get the final shape of the product. Okay, so here the initially what we will do is the billet will heat first, and the heated billet is placed inside the container portion of the equipment, and the ram is moved to apply pressure on the billet, and the metal is extruded through the die. This is how it happens. This is actually a forward extrusion. Here the extruded metal flows in the same direction as that of the movement of the ram. Movement of the ram is moving in this direction, and you will get the metal flows in the same direction. And backward extrusion, it's also called indirect or reverse extrusion, which means the opposite. The extruded metal flows in the opposite direction as that of the movement of the ram. Look at the container, look at the work billet, look at the die, look at the hollow ram. You can see that when you are going to apply, and you can see that this is a hollow ram. Okay, so here the billet in the container remains stationary. Okay, and the ram or plunger houses the die within it. You can see that the extruded metal comes out through the hollow plunger. You can see that this is the extruded metal comes out. അതായത് റാം അപ്പം ഈ ഒരു ഡയറക്ഷനിലേക്കായിരിക്കും പ്രഷർ അപ്ലൈ ചെയ്യുന്നത്, and the extruded metal comes out in this direction. So that's called, it is the extruded metal flows in the opposite direction as that of the movement of the ram. So it's called the backward extrusion or indirect or reverse extrusion. Thank you.